I have an easy and hard integral for you guys. The first one also might not be easy if you do not know the trick. Yeah, but if you know the trick, it's easy. So basically in the first one, you need to use King's rule. Now, what is King's rule? So if you don't know about King's rule, let me share it over here. So if we have integral from a to b of f of x dx, this integral will also be equal to integral from a to b of f of a plus b minus x dx. Now if you want to see the proof of y, you can just take the nth derivative. You will see that it eventually gives the same result. So this is King's rule, and we are going to use this property to solve this integral. Now let's move ahead. So let me light my keyboard here. Now let's begin. Now for this problem, let us first say this as I integral from 0 to pi by 4 of ln 1 plus tan x. And I actually forgot the dx in both of them. I'm sorry for that. And now we can use King's rule. So this gives us that this integral is also equals to integral from 0 to pi by 4 ln 1 plus tan of pi by 4 plus 0 minus x dx. Now this integral is also equals to integral from 0 to pi by 4 ln of, this is tan a minus tan b by 1 plus tan a tan b, yeah, dx. Now we can just take the LCM, which gives us integral from 0 to pi by 4. This will be 2 by 1 plus tan x dx. Now we will have I equals to integral from 0 to pi by 4 of ln 2 minus integral from 0 to pi by 4 of ln 1 plus tan x dx. So now I equals to, this is ln 2 times x, and in x we have pi by 2 minus pi by 4 minus 0, so this is pi by 4 over here, minus, this is our original integral, you know, this is the original integral I, so this is I. So now this is 2I equals to pi by 4 ln 2, pi by 4 ln 2, which is why we will have I equals to pi by 8 ln 2. Yeah, so I equals to pi by 8 ln 2 is there, and this is the answer. Pi by 8 ln 2. Let's go to next problem. It is said to be hard, but it's not. Yeah, I don't think it's really hard though. Now first of all, what we can do is we can change tan x to sin and cos. Ln of, that gives us cos x minus sin x by cos x, so that will be minus 0 to pi by 4 ln cos x dx. Now let us say this as I2. We will do it later on. Let us first do I1. Now I1 is integral from 0 to pi by 4 ln of, if we do root 2, then we will have 1 by root 2 cos x minus 1 by root 2 sin x dx. Yeah, now this is 0 to pi by 4 ln root 2 plus integral from 0 to pi by 4 ln of, this is sin 45 cos x minus cos 45 sin x, so that should be sin of 45 minus x. Yeah, where dx. Now This is just ln root 2. Yeah, and then in terms of x there will be pi by 4 minus 0, so that's pi by 4 only. Plus, now if you use King's rule, you can substitute x as pi by 4 minus x. Yeah, so that gives us integral from 0 to pi by 4 ln sin x dx. So this is also pi by 8 ln 2 plus integral from 0 to pi by 4 of ln sin x dx. Now is this plus? Oh, this is actually minus. I'm so sorry for that. Minus. This is okay. Sorry. This is plus. Yeah, this is plus. Sorry. This one is minus over here, but the other ones are plus. You're gonna find this is plus. Now our actual integral I is I1 plus I2. Yeah, and our I1 is now pi by 8 ln 2 plus integral from 0 to pi by 4 of ln sin x dx minus integral from 0 to pi by 4 of ln cos x dx. Yeah, now this is getting somewhat easier. Okay, now this is I equals to pi by 8 ln 2 plus this is integral from 0 to pi by 4 of ln tan x. Yeah. Now if you want like the solution for each of them, like ln cos x and ln sin x for individual integrals, I will keep a tab over here and you can go to that to see the solution of each of them, but we can just merge them and solve for ln tan x. So I will do this in this video, and so we will have pi by 8 ln 2. Now we can say y as tan x, and then tan inverse y is equals to x, so we will have 1 by 1 plus y square dy is equals to dx. So this gives us integral from 0 to 1 ln y by 1 plus y square dy. Now over here, since integral is going from 0 to 1, modulus of y is less than 1, so that's why modulus of y square is also less than 1. So we can use geometric ratio. Yeah, if we use geometric ratio, we can change this. Yeah, we can change this. Sorry, change this into a geometric sum. So let's do that. We will have pi by 8 ln 2 plus integral from 0 to 1 ln y. This is sum from r going from 0 to infinity of minus y square to the power r dy. Now we can change the sum and integral. Yeah, we can change the sum and integral. R going from 0 to infinity, integral from 0 to 1 of minus 1 to the power r. This is ln y. Ln y to the power 2r dy. Now this is the standard gamma function integral. Yeah, we had minus 1 to the power r over here. And this has a nice solution. So basically, if ln y has power n and y has power m, the solution will be minus 1 to the power r gamma n plus 1 by m plus 1 to the power n plus 1. So I will just do it over here, and then you will see like what is the formula for this. Pi by 8 ln 2 plus this is sum. Okay, how did I? So this is actually sum, not integral. Sum here. and sum from r equals to 0 to infinity, we will have minus 1 to the power r. Yeah, and then for this part, the integral of this part is minus 1 to the power the power of this ln y is 1, and then we will have gamma of n plus 1 is 2 by m plus 1 to the power n plus 1. Yeah, now this sum is actually, if we don't have minus 1 over here, this sum is just Catalan's constant, but this minus 1 makes this negative of Catalan's constant. So we have pi by 8 ln 2 minus g, and that is the answer. So we solved it. This is pi by 8 ln 2 minus g, and this is pi by 8 ln 2. So it seems like this integral minus this integral is actually g. So let's try to prove that as well. Let's try to prove that the first minus second integral is actually z. I'm not sure how will we do that. I'm not prepared for that, but it seems interesting. So let's try to do that. Let's try to prove that I of 1 minus I of 2 is g. So we'll have integral from 0 to pi by 4. This is ln of 1 plus 10x minus 1 minus 10x dx. So this will be the integral I of 1 minus I of 2. Now this is pi by 4. Let's say this is 10 pi by 4. So and that's why we can make it something like this: ln of 10 of pi by 4 plus x. We can make it like this. Now we can further, what we can do is we can just put in place of x, we can put pi by 4 minus x. So that gives us ln of 10 of pi by 4 plus pi by 4 minus x. Yeah, and that gives us integral from 0 to pi by 4. Yeah, that's allowed. Yeah, and then that gives us ln of 10 of pi by 2 minus x, isn't it? And 10 of pi by 2 minus x is just cot x dx. So now this is just minus of integral from 0 to pi by 2 ln of 10x. Yeah, and we know that ln of 10x is just minus g. So this is minus of minus g. So you see, we get that g as the answer. So the beauty of math is, do any way, if you are always going to get the right answer, you can just manipulate and again get the right answer. That's the beauty of math, and we have also tried this live. And yeah, I hope you enjoyed the video. Thanks for watching.